Um, okay, so this time we are on the on-air again, as we sometimes are, doing different experiments. Let me share the agenda. Let me share a link to the agenda as well. There's the link. Google Drive is working finally this time. Good. Feel free to start putting in your updates for folks here that are in the room. So let's see. I guess the first update is just on the status of these meetings. So last time, you'll remember we did the larger meeting, and I screen captured it, and it turns out that really. Let's see. Okay. Okay, let me fix that.
And people who are watching the stream will have no clue what happened. So Stephen is fixing the permission for the agenda.
Okay, try now. Okay, so last time, yes, you should all get access now. Be there, everybody. Oh, access to, is that your Google account, Mark? No. You should be able to edit.
It is a Google account.
All right. Okay. Anyway, while I'm doing this, so we screen captured the Hangout last time, and I did upload it to YouTube 2 days later. The problem was that it didn't capture any of my. So it hurt everybody else, but because I was the one hosting the meeting, nobody could hear me in the final video. So I edited myself out. So it's sort of a bizarre meeting because it's everybody but me. But it was better, I think, to do that than to waste everybody's time watching my mouth moving with no sound coming out. So we're back here to the on-air hangout, and maybe try to do a rotation for people who aren't speaking, try to see if that works. It's also, I realized that the live aspect is a good thing too, because people can come in from the outside and see this while it's happening. There's the Q&A feature. So we're going back and forth and experimenting with a lot of stuff, but I'm hoping that this works for the time being. So. The other option that I'm less excited about, but was proposed on the mailing list, is to use a service called tinychat.com. The thing about tinychat.com is it is much more oriented, I think, to a different slight. It's sort of not a science, not in any way a science-based chat organization, and much of the homepage sort of involves a lot of content that I think is sort of not in the same genre. So I'm a little bit hesitant to use that platform for the moment. It seems to be much more of a socializing network than for sort of any serious business type stuff. So I'm hesitant to go there. But if you feel differently about that, just let me know if you think that that would be a reasonable alternative. It does seem to support somewhat more simultaneous chatting, but it's a bit dubious and not as well integrated, and certainly doesn't go onto YouTube. So, okay. All right. Let me talk about a few other things. So on the agenda here, so there is a project that's shaping up to be incorporated into this, incorporated into OpenWorm, that comes from a different slice of computational biology. But since there have been many repeated meetings on the topic, I wanted to talk about it here, because we may incorporate some of it. And it's currently going under the code name DeboWorm, but there's several things that are cropping up on online issues and this kind of thing. But it's basically oriented around getting computational modeling going along the lines of the development of the worm, which I'm excited about. Folks have asked about it ever since the project began. It's never really been a focus because there haven't been folks that have been willing to run with it. But now there's increasingly a group of 3 or 4 folks that are wanting to run with it, and I'm trying to figure out to what extent it's a separate project and to what extent it's a project that falls under this umbrella. But that's purely based on the desires of those who are interested in making it happen. So I've been trying to create as many connections for folks related to that. It's sort of a new exploratory era. Folks are writing white papers and making proposals, and so it's all very interesting. A lot of it, though, is happening under some side conversations, which I'd prefer, if it's going to be under this, that we can kind of make that bundled under the, so everybody can weigh in on that. Obviously, we've been doing a lot with neuromechanical modeling, but there's no reason why folks that want to, put a development-based project under the same umbrella couldn't work as well under this. So, so I'm very excited about that. Still no right axis? Okay.
No.
Okay. Really? Try again, because I see you right now under can edit on this specific document under that that Google account, mark.watts@utexas. So maybe, I don't know if you're logged in on that, under that account, but I definitely see you having permission.
Okay.
So,
Okay.
Okay, so that's the DevoWorm project. So if you see that flash across the screen or the mailing list, you know what that's about. I'm going to be having another meeting with those guys, hopefully in the next week or so. But that's interesting stuff, and I think a bit different from what we've been talking about, but really cool. All right, what else? So for the 2 Google Summer of Code students that we've got, just as a reminder, we've got evaluations coming up next week. For those folks, that applies to me and Matteo. There's I think that those students have been coming along very well. So for Mark and Johannes, to whom that applies, I haven't done this process before, but I'm sure it's not so painful. So we'll need to submit that to Google. But I've been excited to see all the stuff that's been happening. A lot of GitHub activity for both those guys, so I think it's going quite well. I'll talk about the waffle board as we go through the updates. So rather than kind of go through it right now, as folks give their updates, I may ask you just to say like, hey, okay, is that thing that you're working on the board somewhere, and is it in the right status? So, okay. Next thing is so release 7, the 7th 6-month block of work. We'll be starting in July. Our milestones on GitHub expire at the end of June. So I would ask folks that are in here, if you're not a Google Summer of Code student, because your project is sort of going to cross-cut this, if it's well-defined, please sign up a time with me at the scheduling link here that's in the agenda, that I just pasted in the chat, to spend at least 30 minutes to talk about the closing of Release 6 and the opening of Release 7. And then I just wanted to spend a moment talking about Release 6 and the topics that we had for milestones there, as some of them have had quite a bit of activity, and some of them have maybe not gotten as much as we might like. But since that is going to expire, and last time I think we left those milestones overdue too long, I'd prefer to have new milestones in there so that once June 30th rolls around, we can change them and not have them overdue out in the public, because I don't think that looks very good. So the first major milestone, I think, was around neuromechanical modeling with cybernetic, and there were some issues there in terms of connecting cybernetic with activity of neurons, both receiving muscle activations from neurons and sending sensory signals back to the neurons. And I remember that at that time, we heard from folks like that there was somebody maybe in the Novosibirsk group that was looking at how to collect sensory signals from the cybernetic model. I know that we've been doing a lot on that in that team on getting a paper out, and so some of the modeling work maybe in the last 6 months hasn't moved along quite as much. But since one thing that has happened in the last 6 months, I think that's notable, is that we got this C302 model out. Thanks to Porig. that I think we should revisit this question of, what will it take for us to combine these two code bases? It's very sort of tantalizing in the big picture now. We've got a physical model. We've got, a model that we know does not have all the physiological features in any way, but could be connected in terms of code, to the physics model. And it's very tempting for us to have a unified code base that combine these two. We moved C302 into Geppetto, and folks can play with that now. Not to steal Mateo's thunder. Sorry about that. But but I just in the service of playing the big picture role here, sort of saying like we should go back and realize that we're missing an opportunity here if we're not thinking about at what point we're going to connect these two code bases. In fact, I was speaking with a volunteer just yesterday who has some expertise in C++ and Python, and asking what they could do. And I sort of suggested, hey, maybe you should have a look at these two code bases and see for yourself what you think it would take to combine them. So as we think about going into Release 7, this is definitely a topic that cross-cuts different people's comfort zones and cross-cuts people's projects. So it's kind of up to me to say merge, or if not, explain why not and what is still missing to do merges like that. And obviously, I can do some investigation with these code bases myself too to kind of prompt that. But that's the first topic, and so I just want people to be aware that some of those issues are things that we kind of need to get back to. Another topic under neuromechanical modeling is to make sure that we connect the outputs of cybernetic to the movement validation pipeline. And I know that we've been doing work on that, and we'll get some updates on that as well here today on how to make sure that we can compare what happens with that wiggling worm to what comes out of what we get from the worm behavior database. And then, of course, there's the topic of the ever extended topic of the performance of the cybernetic engine. We heard that we were trapped in debug mode in cybernetic for the last several months. And after getting out of debug mode, we went back, we restored performance up to 7 times better than what it had been for several months once we caught that. So, so regardless of what the performance is, I think we can still be doing work to connect these different code bases together. So I'll be looking to have these conversations with you to intersect on these topics of what is the next step with the neuromechanical modeling that we can practically do as we think about Release 7. And obviously that touches several different people's interests. Anybody want to comment on that big picture without getting too much into an individual update? Does anybody want to say anything about whether that's interesting or not interesting, or well-timed or not well-timed, or just make any comments about neuromechanical modeling?
That's all good.
Okay. All right, I'll keep trucking along. So Geppetto, so running network of 302 single carbon neurons in Geppetto. Looks like we actually got that. This has been sitting on here for a while. Again, I'll let Mateo say more about it, but that's awesome. Worm body model from cybernetic integrated into Geppetto as well was something we talked about. That obviously will be slotted under WormSim, and I'll let Mateo talk more about some ideas with that. But so then, as we look for Release 7, it'll be interesting to think about what will be the other things beyond that. Maybe I think the whole release can potentially just be dedicated to that. But as there's a lot of open source energy heating up under Geppetto, there's potentially the room for several other things. These I think replay is a topic. Obviously, Johannes working on that sort of stuff. So as we think about what the public milestones will be for that. I think very interesting to consider what will the use cases look like for replay, and what will the use cases look like for the worm body model, and all that kind of design work that's going on under there. Movement validation, Jim, Michael will be talking to you guys to see that. I think that really integration with the rest of this stuff probably could be the major milestone in the next 6 months, and getting maybe more specific on what those milestones are. Balash has been working on the motif analysis, and I'm not sure if in the next 6 months the publication will be out and we'll be ready to integrate some of that stuff, but we can certainly plan for that. Optimization engine stuff, which I think was a little bit shoehorned into this past release, in terms of maybe we didn't get a clear bead on what we would do there. This might actually be something we can now take up in Release 7 with a bit more focus, specifically on building a fitness function. So we'll talk about that. Data collection and representation. This got a big boost when Mark joined us for Google Summer of Code. So this build data model pipeline is actually, I think, well taken care of by him. And so we'll be looking at the next steps there that are based on the roadmap that Mark has laid out. And let's see, NeuroML model updates. So yeah, I think again, Porg, was the hero here in getting C302 out, and I think it's really up to him, sort of what roadmap you see for steps beyond C302. But I've been pointing lots of people to C302 like crazy who've been coming in, and so there's a lot of people looking at it, evaluating it, and getting it to run. So I think it's just a question of what folks are going to want to do. But that's been really great progress in the last several months. And then let's see. So we got Perspectives article out for review. Bravo to Balash for that. SPH paper. We actually are. I know that folks probably hear about this every time, and it sounds like it's never making progress. But in fact, we have been making constant progress on it. We have all the sections now. We have an introduction, methods, results, and discussion section for this paper. We split out some of the stuff that was more specific to muscles and the worm body in order to have a chunk that we could submit to a journal sooner rather than later. That is actually well on its way. The figures, I think, are about 95% finished, and we have the final figures that we want to have in there. So we're actually coming very close to asking folks to review it as a whole and kind of get it out there. So that has actually made some good progress in this last 6 months. Outreach to biologists. Actually, the Kickstarter helped that move forward as well, because we emailed a bunch of people and pointed them at the scientists page. We created the page, the scientist page, in the last 6 months, and so no less than 650 C. elegans scientists were at least emailed about it, and a bunch of comp neuro people as well. And then, of course, the fundraising Kickstarter, we kind of got that done. So. Okay, so we've actually had quite a successful Release 6, actually, if you think about it in aggregate. And so planning Release 7 will really be carrying over things that didn't get as much work, and then taking things that we did accomplish and thinking about what their next steps are going to look like. And the due dates for that will be around December. So really be thinking about, in the course of 6 months, where you'd like to be with the project and what we'd really like to see. Okay, great. So any questions about that before we move on to individual updates? I will be making a more formal sort of write-up of all of those updates, by the way, that I just went through verbally. But I'll probably do that after the round of talking to everybody and just kind of hearing from folks. But we'll post that in a way that is accessible to everybody. Okay. Great. So let's go around. Looks like first person on the list today is Andre. Andre, hello.
Hi guys. Well, today not much words, but quite significant result. I have finished doing work about removing doubles and leaving only floats in calculations in OpenCL. So there was a problem that some values which we use are out of maximal and minimal values, which are which is well, every float can take some minimal, maximal value, and some of them which we needed to use are out of this interval. So we know that float is around 38 degree is the upper limit, and for example, one value is 44 degree. So I have found combinations of values which we need to use, which are like a very big number multiplied to a very small number. So a combination of them gives like some average degree of 10, which is okay for float. So I have found all the combinations in the code which are connected with previously doubles were used here, and now pre-calculated combinations of doubles in the code outside of OpenCL, such that I pass into OpenCL functions already multiplied with each other, such combinations, all which are necessary. So now it works. Now OpenCL code has no any double value, and I hope next time I will try to test it on graphical cards, and if everything will be successfully, it will work after some improvements. So if anyone got a powerful GPU card, you can have significantly faster calculations. And of course, well, except this, some progress on a paper, on this page paper. And one more thing, there was also one more problem around floats and doubles with a limited number of digits which represent each value. This problem was connected with error of integration during multiple steps. There was a lot of issues, well, a few but long issues on GitHub, discussions about integration, its problems, different integrators, which are the best, and so on. I have performed some additional testing around this. So when we start, when we consider a single particle within the simulation, for example, like mass which hangs on a spring and it starts some oscillations, if initial coordinate of this mass is 0 or near 0, then all digits of the float number which stores the coordinate can be used to store even very small changes of this coordinate at the first steps of the simulation. It's very important, and then the rest of them. But if we start from some quite big value of the coordinate, then there is one digit of the float for this initial value, and only very small digits, a lot of zeros after that biggest one, can store that changes, very small changes at the start of the moment. So there is big difference in behavior and in precision of the integration algorithm, depending on what value of initial coordinate we have, 0 or quite large, in comparison with the amplitude of oscillations of the sinusoid, for example. Now I have calculated the dependence of this error of integration on this value of initial coordinate. And I have found that in our case, we have quite small error which we can neglect, which we cannot consider. If we have the size of the simulation box less than hundreds of thousands of individual particles. So if you will have larger than 100,000 particles, then initial starting coordinates for very far of them, which are most far from 0 point, will have that error, which we will see. I will write all this to continue the discussion. It's very interesting, but the practical result is that in our conditions in which we plan to work to simulate the worm and so on, we will not face with this problem. So floats and doubles in this reality in our conditions work with the same precision. So everything is fine until we do not have an enormous amount of particles in one dimension.
So Andre, two questions. One, I just pasted a GitHub issue into the chat. If you can look at it, I'm wondering if this issue is the one that's most similar to what you're investigating. That's the first question. And the second question is this topic of doubles versus floats. My understanding is that the ability to support GPUs depended on having all the same type, one or the other. At the moment, I can't remember whether it's all doubles or all floats. I'm sure somebody can remind me.
It was the problem is that some GPUs do not have support for doubles.
Right.
So, but
right.
All the GPUs do have support for float.
So I guess my second question is: Are you interested in are you working towards making it all floats again, so that it can be we can get back GPU support, or is that not as important to you right now? Do you think?
Yes, it's important, and I have completed it.
Oh, okay.
All OpenCL code now is free of doubles, only floats.
Okay, great. And is that in the master branch, or is that just in the dev branch?
It will be in development branch. I hope I will upload it tomorrow.
Okay, cool.
When I will be at work.
Okay, great. And then this issue, this one about integration?
Yes, this issue is about this problem.
Okay, that's what you're talking about.
Well, I will add a few illustrations, and it will become clear what I was attempting to tell here.
Okay. Okay, great. Perfect. Good. So that one is still in progress. Okay, great.
Andre, one question. For the float support, so now all the doubles are gone. Did you have to make any assumption on what kind of particles scene you're simulating in order to go from double to float? Or no matter what configuration of particle we do have at the start, we will still be able to basically use it with the new version, which only relies on float. As in, does it depend on the configuration of particles, the fact that we can have a float or not?
If you ask about geometry of the initial scene, then everything will be okay. If we change the scale, like distances, particle radius, particle mass, then some balance can change, but there is still a simple way to check out if we are still in correct interval or not. It works like, well, instead of doubles, now I use combinations of very large number and very small number, which are used in various formulas, which in result get some very limited values like density, which is about 1000, while multipliers are maybe one constant is 10 in degree like 38, and one is something like 10 in degree minus 14. So a combination gives
Okay.
one and second in some second degree. So I just calculate all these combinations which I know from the code, those which I need. They easily fit flawed boundaries, smallest and largest. So I easily operated them without getting out of borders.
Okay, but
minimum and maximum.
Okay, but does this? So are you saying that there is a range of values, for instance, for the mass of the particles and for the distance between the particles that you have found a combination of small numbers and big numbers that make everything fit into float for these ranges that you're working on right now, and that with different ranges, for instance, if you have a distance which is smaller or bigger than that range, or if you do have the mass which is bigger or smaller than the range, that it would be a matter of finding new combination of values so that the end result would still be within float?
Oh.
Or not? Or did I get it wrong? Because that's the most likely option.
It's highly probable that in a wide interval of values of distances and masses, every combination will every two numbers, big and small, will balance the result, and this tendency will be in all interval. The nearest problem which we can face will happen if we will have, for example, the mass of the particle 5 orders of magnitude less than now. Now we have 10, nearly 10 in degree minus 14.
Okay.
So if we will get 10 in minus 19, some other parameter will get out of float maximal value, and this will cause error. But now we are 5 orders of magnitude from this error, quite a lot.
Okay. Is it possible to write down what is the interval that we can safely be within in order of what is the smallest mass that we can have, what is the biggest mass that we can have, what is the smallest particle distance we can have, what is the biggest particle distance we can have, in order for the algorithm not to break, basically to not to overbound, because so that then we can do some validation. Because, like, take for instance Geppetto, where you can just pass in any configuration of particles, and the user could decide for a mass to have a different value than the examples that we have. If we end up having a range that we need to be within, then we can think of having some kind of model validation, so that if the configuration of particles that the user is providing falls outside of those ranges that we know we can be within, then we at least give them some kind of error or something like that. This is not, it's not possible to simulate such a model with the current version or something like that. So to just figure out what is the range that we need to be for the mass and the distance to basically not break the algorithm. Would that make
Definitely,
sense?
yes. Yes, of course, I can find all the minimal and maximal values, and there is a very good and wide range for each.
Cool.
Yes, if it's interesting, it can be easily done and written somewhere.
Yeah, so that we just have the requirement for what kind of model we can create with the that we can simulate with the new version. Cool.
Okay, Matteo, I think you're.
Sorry, Stephen, what did you say? Was that the
Matteo,
only
I think
one?
you're next. Sorry.
Okay, so we're breaking up. Okay, so let me bring that clear again. So yes, these 2 weeks, the agenda is. I will update the agenda later. Otherwise, I will spend too much time talking. So I've been working on the release 0.1.4 of Geppetto, which went out just a few days ago, and so there is a release notes for that, and the live deployment has been also updated. So at live.geppetto.org there is the latest version, which is deployed as part. I can. Well, there is quite some work that is going on at the moment on Geppetto from contributions for different. Okay, I think the server crashed. Okay, I want to show live.geppetto.org, but I will have to check what happened. And what I wanted to show was the one widget that was contributed to Geppetto by Boris and Adrian. That basically allows for plotting plotting states in 3 dimensions. And one of the things that was added to 0.1.4 was a sample using this widget of the Hindmarsh rose spiking neuron that is now added. And another example that was added was the C302, which is now available from the drop down of the sample. So it's much easier to get access to it. Obviously, it's experimental, and it's a model which is in constant evolution. And but at least it's now available as a preview, let's say, for people that want to play with it. The other few things that went in are so the new version of Float, which is the library we are using for 2D plotting, went in, which means that now plotting is faster than it was, and it consumes less CPU, which is good, especially when you're using multiple widgets, as we're doing. And the other thing that it looks like I also managed to fix was the problem that happened on Windows with the basically wrong serialization of JSON when the server was running on Windows. So Johannes got back today saying that is also fixed. So that is good. And we had the meeting for Geppetto on Monday. So we're having it every 2 weeks. There was a lot of progress from different people, and so I'm just summarizing some of the stuff that was reported as part of that meeting as well. So there is in these days we started working on the design for the worm scene. So with all the different features, is a lower level design compared to the one that was made pre-Kickstarter planning. So right now we're going down to lower level of detail in order to figure out all the different things that need to happen, how things are going to work, etc., etc. And I think that is pretty much it. Unless you can think of anything else I'm forgetting. No, then that's it.
That's good. Okay, excellent, good stuff. Let's go on to Giovanni.
Hello, everyone. So, last few weeks, busy doing a number of things, notably after the Kickstarter, put a lot of effort into sending out the surveys to the backers with help from Stephen, and sent out the surveys to the backers. And if you did pledge for the project, then you should have received one. Sent out the surveys to the backers, and most people already have filled them out, but we're kind of estimating leaving 2 weeks for basically allowing 2 weeks so that everybody gets back. In these 2 weeks, you're basically preparing for ordering t-shirts and posters and stickers to fulfill the physical rewards with the information that comes back for the survey. So there's quite a bit of work that goes into making sure that all that stuff is ready to go once you get the addresses. And doing a bit of work around that. Then we did restart the Kickstarter committee meetings with a meeting we did today, and I have another one in 2 weeks. 2 topics came out of that. You're gonna see a few emails on that topic. Then that's pretty much it about the Kickstarter stuff. And I did start working on Geppetto again. Now I have a bit more time after the Kickstarters ended. And I did work with Matteo on some design tasks for both generic Geppetto stuff and WormSim. For Geppetto related stuff, I think Matteo covered a lot of the stuff, but we work on tree refactoring design, and that means something fairly specific that I don't know go into much detail here, because we have Geppetto meetings every 2 weeks on Monday. So if anybody's interested to know more about that, they should join those meetings. So basically, the thing to know is that there's a lot of refactoring design going into Geppetto to extend it in view of the WormSim stuff as well. Yeah, I did spend a lot of time with Matteo working on that. Looking at diagrams and things that you can see the diagrams popping up in the cards on the GitHub OpenWorm organization under the Geppetto root, OpenWorm /ordo Geppetto root. So I do have another card assigned to me that has to do with refactoring on some of the front end stuff. That I started looking into, but I haven't written any code yet. This is a link to the card, but that's on my radar. I put my name down for that. So my face should be on the board. I see that it's still assigned to. I know it's assigned to me. Perfect. Okay, so that's very much everything from me. Again, I feel that if people are interested in the details of the design tasks, and if anybody wants to get more involved, they should show up at the meetings on Monday, where we have extensive discussions about this stuff. So I think that's pretty much my update.
All right. Let's see. It doesn't look like we've got Sergey here. So let's go on to Porig.
Okay, hi. Yes, unfortunately, I don't have very much to update since last time. Most of the work that I've been doing related to this has been general kind of improvements to JNeuralML, which is the Java package for loading, translating NeuralML 2 models, and is what's used by C302 for running it.
a lot of those have been related to making sure that multi-compartmental models will run on this. So eventually, further down the line, it'll be useful for OpenWorm, but most of the stuff that was needed there anyway for C302 is there anyway. I haven't done too much on C302 itself. There have been some mails and comments from Tom on the mailing list. Most of the things he's asked for I can do, but it just needs to a little bit of time to modify the code. So basically what he needs is, the way it's structured at the moment is that you can change the individual cell properties. So there are integrated fire neurons, and you can change the weight, the overall weight of the excitatory connections and inhibitory connections, and see what the network does. But what he obviously wants to do is to be able to change individual sets of connections. So I'm going to have to try to update the code so that he can retune that, so that he has more freedom in tuning the network. It does bring up some philosophical questions about whether you, if there are 10 connections between two cells, whether you, if you set these to 0, whether it's still really the C. elegans connectome. But I think we shouldn't probably worry too much about that for the time being. Let's just try to get it to do something and connect it to Geppetto and Cybernetic. So hopefully in the next week or so I'll manage to make some of those updates, but I think he can work with most of what's there at the moment. The other thing I've looked at quickly is Pi OpenWorm, and I know, Mark, that you've had some pull requests. You've been looking at C302 and some of the regenerate connectome scripts there, and that's all great. I mean, that's exactly what it's. It was kind of hoping that something like Pi OpenWorm would come along and be able to slot into this, so it's great that you've managed to use that. The one thing I would say is I have a few comments that I've mentioned there. I might just go through them very briefly. I did have some issues with installing Pi OpenWorm, some issues with RDF-lib. I'll test that again. I think I've had various different versions installed, so I think I just need to test that once or twice more to see which version I'm using, and just maybe put in a check on the different version. The main thing that I was reluctant to accept a pull request yet is that it's obviously in your own repository. What would be much better is, especially if this is going into the core of C302 or regenerate connectome, is that if there'll be a stable release. So, I mean, ideally, it would be nice if somebody else who downloads C302 can get this from something using pip install, even if it is an older version, an alpha version. If they have to find out that it's your particular repository on a particular branch, then it's going to be more difficult for somebody to install these scripts. So it's probably higher priority to just get a release of Pi OpenWorm out there with even it's still in development API with some more examples, and then that can definitely be integrated into C302. The one other thing, the main other thing that I was concerned about was making sure that the data that's in there in Pi OpenWorm is the same data as is actually in the spreadsheet that's under the C. elegans NeurML project, because I know that we've had some slight updates to what's in that spreadsheet over the last number of months. I know that in Tim's database there's been some minor changes in the contents there. So before actually substituting either for NeuroConstruct or for the C302, the contents of Pi OpenWorm, it would be good just to actually be able to clarify what's in the different repositories. And that's, again, related to having a stable release with some more examples that we can just manually go through it, because I still, I mean, haven't got it locally installed, and I just want to write some examples for my own benefit to see how it can be used. I think that's most of the thing, and maybe, well, actually, maybe it might be useful if we go on to Mark next to actually discuss that. But the one other thing that I thought might be useful, as I mentioned in my summary there, is maybe an OpenWorm data manifest. So basically just a summary of, either on the website or probably would be better actually if it's on the PyOpenWorm repository of where all the data has come from. Now, ideally, you can get all of this through the Python API itself, but if there's a one-page summary saying, okay, we're using this data from the spreadsheet, this has been included, there are these other data sources that we know of that haven't actually been included in PyOpenWorm. If that's a living document associated with PyOpenWorm that can be kept up to date, so we know what's in there on one A4 page or on one markdown document, I think that would be very useful so that people can actually see that, okay, this is what's in there, because I don't know what's in there, I don't know what stage that spreadsheet has been updated, and I think it would also be useful for the project saying that, okay, these 3 data sources have been incorporated, but these 4 other ones haven't yet. So that's basically my impression. And again, I'm sorry, I haven't gone through it in great detail, but I think, yeah, definitely this approach of having this single point that you can just include would be very useful. And if all the annotations for the data provenance is included, then that would be ideal. But I think, yeah, I mean, a stable release would be a really good point at which to look and make sure that everything's there. So,
all really good suggestions. I think it's all really valuable, and I think those should get turned into, we should turn those into issues on the PyOpenWorm repo to make a new release from that. So very, very helpful to actually review all that stuff and all the issues that raises. I agree as well. Mark, do you want to update and speak to those things now, following on Park's comments?
Good. So as far as where the data is coming from, everything that's in the database I have on the DigitalOcean server, that's all from the SQLite database that was in there originally, and I think that actually came from the spreadsheet that we were talking about, or from the MySQL database. So as far as like comparing what information is in there versus the other sources, I guess we could like have something like, you know, look at each of the like synaptic connections and things like that, to make sure that they're the same between both of them. I don't really know what the updates are between you know, when I started and you know, when different versions of the, you know, connectome got split off. So
yeah, I mean, that was one of the motivations for having this separation for the, as you had the OpenWorm data reader and the spreadsheet data reader, which had the same interface. So basically, you could query the contents that you had developed originally, this kind of wrapping object for the connectivity data that was provided a unified interface from whether it was from the spreadsheet or whether it was from PyOpenWorm. So I thought that in your latest pull request you kind of moved away from that, but there should definitely be some test scripts which, and maybe actually it might be useful to move that or make a copy of that spreadsheet into PyOpenWorm and have maybe some separate module which reads that data. It might not be at the core of OpenWorm, and might be even just completely separate scripts, but if that's moved into that project, then we do know that, okay, the latest version of the spreadsheet is in that project, and we can read data from that. We can read data from PyOpenWorm. That makes it much easier just to pull data out from the two of these and see where the inconsistencies are.
yeah, that kind of speaks to a problem that I've been wondering about, like, you know, how people are updating the data, because I don't know how often we're changing that spreadsheet and whether we should be, and how we keep track of that. I know there's some versioning on Google Docs, but I don't think that's like...
Yeah, and yeah, again, this would be why it would be useful to have a single page that's on the PyOpenWorm repository listing all the data, and that's the Bible as far as the data in OpenWorm in general is concerned. If it's not listed there, if it's not pointed to there, then it shouldn't be considered actively used data. And then we can keep that in sync with what's actually in PyOpenWorm, what's being used in C302, what's been used in various other locations, and have that as the central point for which data and which versions people should be using.
I can do that. Just writing everything up.
Yeah, I mean, I think Stephen as well, maybe if you can contribute to making sure that that's the most up to date, and maybe just publish it or push it out on the list just to make sure that people know that, okay, well, this is going to be the central point, the master information about what data sources are out there and what data sources have been included.
Yep, I've just made an issue on the PyOpenWorm repo to that.
Yep. Actually, Mark, if it is possible to actually work in branches on the main PyOpenWorm repository rather than in your own repository, I think it might be easier from the point of view of people switching between branches and also tracking issues. And I noticed, for example, with the Travis scripts, it looks on your repo like the Travis tests are passing, but actually the green light on your repo is saying that the OpenWorm / PyOpenWorm is passing rather than your own repository is passing. So I think it's handy to actually keep this in one place, and even if it's separate branches, and I think it would be much easier to keep track of developments that way.
Sure, I can just put on a pull request to the main repo.
Yeah.
Very good. Okay. Let's see. Anything else we want to say about that, Mark?
I think that actually is most of what I've been doing. I've pulled in morphology data from the C. elegans connectome project, and that's looking fine. I thought some about what actual physical storage you would have, but at this point it's mostly just one database. It's using OpenRDF, and we can use pretty much any server for that, so I'm not concerned about that.
Okay.
And then I haven't done too much with the worm development. I know that Steve and Richard have been talking on one of these issues here in PyOpenWorm, but I'm not really sure how I could actually contribute to that right now.
That's okay. So for you and for everybody else's purposes, right? So I think that your progress has been very clear in terms of defining an API or the extensions to the API. We've sent those around for comment, and the stuff that involves them, the cell lineage stuff and the development stuff, are some of those API calls. So I think that's the main intersection point. And so now, if you're focused on just implementing those API calls, then I think that you're good. We'll get the data that goes behind those calls from them or from other sources or whatever. But I think that now we can turn our attention to just that implementation. And like I was mentioning at the top, I'll be seeing the prospects of looping that in and making that its own sub-project as well, the development stuff. But I think that we've had good interactions so far with that. So. Cool. All right, very good. By the way, Matteo, do you know if Johannes is around somewhere, or if he wasn't going to be able to join us today?
I don't know. I can report what he has been doing with the recording format.
Yep.
So basically, it's not well. Everything is recorded as cards on Waffle. So, but there is basically there's basically two main things. What was going on was an exploration of an SDF, which is the format that was proposed by the group in Poland, and we had a meeting. We had a meeting with them. We compared the format, and basically we agreed that it was good to not duplicate any effort, and they created a proposal for how to modify the original proposal in order to make it a bit more generic, domain agnostic, and less about neuroscience. And there were two samples that we received from them. So Johannes is going to work on these to try and further improve it. And he is now in the process of creating a new sample that then we will feed back to them for hopefully a final approval, so that after that we will basically, once the structure is agreed, we can move on to the coding, and so that Johannes can move into the conversion from the different simulators. So that is the current status of that.
Okay, cool. I believe Rainer is next.
Okay, hi.
Hello.
Okay, so just to recap what I've been working on, I've been working on modelling the neuromuscular junction using starting with the muscle model repository and using Neuron to create a working model of the muscle cell itself first, and I've been trying to replicate the results in a paper by Jordan Boyle and Netta Cohen from 2007. Okay, so using Neuron, I've now got a physical model of the muscle cell that's identical to the one that they've been using in their paper. So I've got the same cell compartments and dimensions as they describe in the paper, with the muscle cell body with multiple arms attached to it.
5 arm compartments each?
Yes, they've got 5 arms per cell and 10 compartments per arm. And yeah, the cell body itself is just a single compartment. Okay, the ion channels that came with the neuron implementation in the muscle cell model aren't the same as the ones in the Boyle and Cohen paper, but looking under the NeuroML2 directory, they already seem to be NeuroML representations of the 4 channels that Boyle and Cohen were using in their paper. And also the Appendix A to the paper lists all of the electrical parameters that they've been using. So I've just been going along plugging those in and getting things working incrementally closer to the actual experimental results that they reported. So yeah, making progress bit by bit. It looks like I'm getting close to the end of modelling the muscle cell itself. So yeah, getting close to the end of the first stage of this, and hoping that soon I'll be able to move on to stage 2, which would be plugging some synapses into the ends of the muscle arms and seeing if we can get voltage spikes in the muscle cell body.
Okay, is any of the code you've described on GitHub yet, or?
Not yet, no. What I should probably do is make my own fork and put up what I've done there. I've just been working on it locally so far, so
yeah. Bear in mind as well that with those channels, the versions that are in NeurML, there is still an issue with one of the channels, the inactivation, which seems, I forget exactly what the issue is now, but it did seem that some of the figures given in the paper, it kind of suggested that the channel would never fully open. I think I did mention it on one of the issues there, but again, the NeurML version of that model isn't fully finished. It does work, it does things, but don't rely on the fact that it does everything that's described in the paper. It's a partial implementation, so be careful with that.
So I noticed there were some comments in some of the files to that effect. Yep. So yeah, not exactly the same. I think in the paper itself, their model didn't exhibit the same spiking behavior as we see in actual in vivo experiments.
Yep.
So yeah, it's a starting point rather than an exact reproduction of what we're seeing in nature, but at least it'll be a close approximation that we can work from, I hope.
What I've been impressed by the way, as a point of comment, because I've been meeting with Rainer here almost weekly, moving this forward, is that he sort of trained himself to be a computational neuroscientist here, just from materials that we've been passing him and things that he's been picking up from the repos, and so I've been very impressed, and we are, and we have been using the Netta Cohen paper as the starting point and digging back into the graphs from the source material even that they're citing, and so the purpose here is to use that the actual physiology traces as the standard for what we're creating here, and yes, I guess we're now getting to the point where we've crossed over the hump of the learning, and you're actually producing stuff that's worth starting to contribute back. So I think now is a good point to create a fork and to start putting some stuff into it. But it's been going quite well. I think he's sort of pretty much picking up where where Mike left off on that muscle model project, which is very impressive for someone who's just coming into this area fresh. So I've been very pleased with how fast you've gone, really, in just picking this stuff up from scratch. So.
Thanks. It's a massive amount to absorb, but getting there slowly.
Very cool.
Okay, thanks.
Okay, good. And we'll have another session, I think, later this week, too.
Tomorrow, I think.
Yep. Alrighty. Last but certainly not least, Michael has been patiently waiting. How are you doing?
Hello. So let me deliver an update on behalf of Jim and myself. Jim's been doing a ton of work too, so don't let his absence have any meaning attached. He's been working very, very hard. In fact, over the past few days, the past 2 or 3 days, in fact, we've been making kind of a last-minute push to finish that porting from MATLAB to Python for our movement validation repository, because as you recall, last meeting we had promised that we'd finish that by today. So we did achieve the significant milestone that all the code is moved, but some of it unfortunately remains hermetically sealed behind commented out sections, and we still need to actually activate it by translating the final few hundred lines of code. So we're just about there. I think we're basically saying that 1 or 2 days effort is remaining to finally complete that. Once that's done, we're thinking that some next actions that we should probably still complete to really finish this release 6 version, and then move on to some of the things that Stephen, you were mentioning we could be doing for release 7, like connecting it to the rest of the project, and possibly adding psi unit hooks there, so that we're using some of Rick Gherkin's work there. But some next actions might be defining inputs to the pipeline, basically doing a lot more work on the beginning upstream stages of the data pipeline process, so that we're actually transforming a more raw state, closer to what the actual raw video might be, to the normalized worm. Right now we're doing all of our work starting at the normalized worm stage. Normalized meaning segmented into 49 skeleton points and nicely laid out. Of course, that might not necessarily be the case for the data that's given to us from Geppetto, so we might need some processing there. Also, the statistical computation of the features needs to be completed, and then packaging that all up together into a kind of fitness function for the Turing test. A little bit more documentation of the feature calculation. We've worked on that, but it's still not perfect. And finishing the saving of the features to the disk, so that we actually have the end of the pipeline finished and it's outputted there. And then possibly expanding some features. Jim is very excited about the idea of really actually digging into these features and understanding what they mean and what they do. I've just sort of been blindly following the Umini paper and just trying to code it, but I know Jim's really interested in kind of examining the consequences of these features and maybe finding some better ones or some different ones.
Okay. Do you think by next time maybe it would make sense to just walk through a little bit of the code and just so folks get a little oriented to this, because I know that you guys have been working intensely on it, but I think that maybe just a review of what are the new pieces once they're all there, and how we can think about potentially crossing them over with some.
That's a good idea. Like kind of a show and tell thing would be a good idea.
Okay, cool.
Yeah.
Awesome, awesome. Very good. So yeah, like I said here at the top, and was that all, Michael? By the way, sounds good.
Yeah, that's everything. Thanks.
So like I was saying at the top, so all these things happening in parallel are great, but I do think that it's now time for us to think about the intersection points again. It's very easy for us to kind of be on our own little rails, but we have an awesome opportunity to put all this stuff together. Just as a comment, we tweeted an article by Christoph Koch that came out in the Technology Review recently, talking about what it's going to take to crack the neural code, right? Crack the neural code. And I'm just sort of reminded that, like, cracking the neural code has been sort of the goal of neuroscience, I think, since it started. And so, although sort of couched in new language, I think we still have this fundamental confusion about how neuronal dynamics relate to information processing. And, you know, it's easy for us to kind of get in the weeds of coding in this project. It's certainly very easy for me to do that. But when I remember and read articles like that and remember the opportunity that we have here, which is really to constrain what a nervous system does through behavior, and have a functional standard for what it means to achieve that output, right, which is based on the statistics that we're getting there. We have a physics engine that's capable of showing us what the body should be doing. And we have the code for a nervous system, of course, with lots of gaps in it, but we have the code for driving a nervous system. We have this opportunity to really get at this question of what is the neural code? What is the neural code? To crack what it's doing. Obviously not in the sense of spikes, but in the sense of how do these changing activity patterns of these biological cells result in some sort of manifest behavior. And so I just want everybody to remember that as we are doing all our individual work, that this larger purpose of cracking the neural code is one of those exciting, tantalizing things that we are heading towards. Let's not ever forget that. Let's always remember that that is the context in which we can make a difference with OpenWorm. And I think it's very exciting. I think it's a very exciting prospect. I think that all the tools are really there, but we have to focus on integration. We have to focus on putting these pieces together so that we can do a full loop through all of this, from the nervous system to the body to the data to making sure that the muscles are doing the right thing, to making sure that the tool chain works, to making sure that it's visible on the web. All of these pieces that we've all been working on individually, we are coming to an intersection place. And so this last 2 weeks, I started that chat channel that folks hopefully saw as a way to get people talking even further. I know that it can be a little scary to be chatting to such a large room of folks, but don't hesitate to communicate more, guys. And I'm going to try to foster that as well as much as we can, so that we can really get excited about the intersection points as well. So I will leave you again with this little link. Please sign up on time outside of the conversations that we even regularly have that specifically focuses on Release 7 and what that will be. Yes. Okay. If you were not added on that, Mark, yes, I did actually add you on that. When we meet, I'll tell you about it. But I included you as well on the Google Chat Hangout. So if you haven't seen it, maybe you need to dig into that list of your Hangout list. I'll show you where it is. But you were on there too. Yeah, but sign up for time for Release 6 or 7. If not, I will pester you here in the next couple of weeks so that we can get that roadmap set for the next 6 months as well.
Steven, speaking of communication, I did write on the chat the other day about the organizing a journal club with the MIT group.
Yes.
What do you think about that? Because I can go ahead and do it, because I would be very keen on getting to collaborate with their output and seeing what kind of form has their output in terms of data, in terms of what has been recorded, and if they would like to feed those data into the OpenWorm project and do those kind of things. What do you think about that?
I think it's good. I think the challenge with journal clubs right now is that there's a backlog of them. So there's interest in doing a journal club on the recent biological updates on theories of how the nervous system controls locomotion. There's a journal club that's been proposed for Rick Gherkin to talk about Psi-unit, and then there's this one, which you're talking about. The other issue with that is that I want to understand better how Ed Boyden's contribution relates to the work of Ali Pashi Vaziri, who is the developer of the light field microscope, as well as the two individuals that we had on talking about the version of the paper in the head neurons, right? So if you'll recall, 3 months before that paper came out, or so, maybe it was 6 months, I don't remember. A while back, we had a journal club with essentially the same group minus Ed Boyden, minus the MIT group, talking about their ability to visualize the neurons in the head. And then we got this paper, right, which came out in Neuron. So it seems like 90% of the effort began with the Vienna group. And so I want to understand if we now go and say, I just want to understand within that group, who is the main representative of that effort? It's obvious that the MIT group is involved, but do they consider themselves to be the drivers of that, or are they in addition to the work that's already there? And so my thought was actually the next time I was in Boston, I would sit down with Ed and see what he thinks, and to better understand kind of what they're thinking about the future of that project is. Basically understand what is their future direction. So I completely agree that it would be very powerful to have that data in the project, and I'm definitely focused on that. My question about organizing a journal club is that the best way to do that, and is now the time to do that, and which is the group to have on to speak to it. As you remember, in the past, we've often aimed at the graduate students that have actually done the work, as opposed to the PIs, and so that's another thing too. So maybe you and I can talk more about it too. But so that's kind of my thoughts, as opposed to just like sort of sending him a mail first and asking him to do a journal club, is just for us to do our due diligence to better understand a little bit more about the situation behind the scenes, so that we get that. So hopefully that makes sense.
Yeah, I'm more interested in the final result rather than the process, as in getting the interaction data output, learning more about that. If you want to send an email, if you want to reply there, if you want to pick up the phone, let's aim for that to happen.
Okay. Yes. No, I agree. And the last mail, right, that Ed put out on the list was sort of suggesting that it can actually be very valuable as a two-way conversation. It seems like the folks that will be thinking about the problem of how to extract full neuronal activity using that technique and turn it into something useful will need to think about things like what is the anatomical model of the neuron so that they know what pixels relate to activity in what neurons. And so having a model almost is required to do the right kind of image processing to get that data out. So it sounds like it could be a very fruitful two-way interaction too. So yeah, actually having a hangout first is probably a good idea just to start that conversation. Actually, I think I'll make that happen here in the next 2 weeks. So thank you for that. Yeah. If folks didn't see that Nature paper, that Nature Methods paper, by the way, that is a big deal. I think we talked about it in a previous thing, but that they extended from just getting the head neurons to being able to image all the neurons in the C. elegans at the same time, which would mean, like, it would be really exciting, like for Michael and Jim, it'd be really exciting if, imagine doing the whole worm behavior database, but on top of having all the behavioral motions, that you could also capture all the activity of all the neurons. That's, I think, still a bit a ways away for free-moving neurons, but not impossible. And that's like the gold standard data set, probably even beyond the worm behavior database for us to do a neuromechanical model. Then imagine that all the muscles also have their activity. You can image those too. Challenging from an imaging perspective because they're all going to be on top of each other, but it's get ready. Cool. Thumbs up. Okay, guys, anybody else want to make a comment here before we sign off? All right. Awesome stuff, guys. Good progress, everybody. We'll do this again in 2 weeks, and we'll see you guys online until then.
Thank you.
Thanks, bye.
Cheers.
Hey, guys.